All right, let's dive in. We're going deep on something pretty wild today. Stephen Wolfram's theory of everything. And to help us unpack it all, we've got this really cool YouTube video from Platzi.
Yeah, it does a pretty awesome job of making Wolfram's ideas a little less intimidating, you know?
Totally, because this guy, I mean, he's got this background in physics, right?
Yeah, and computer science.
Computer science, so already you know he's thinking about things a little differently.
Definitely, and that really comes through in his work with cellular automata.
Oh, like Conway's Game of Life, right?
Exactly, where these super simple rules end up creating these crazy, complex patterns.
And he's basically saying the whole universe might be working on something similar.
That's the gist, yeah.
Yeah.
It's all about how simple things can build up to something way more intricate.
And that's where the hypergraph comes in, right?
Yep. But it's not just your average network.
So not just like connecting the dots like on a map.
It's more like each connection also holds this information about how it changes over time.
Oh, so like a 4D map, kinda?
You got it. So it's this ever-evolving, multi-dimensional network that Wolfram sees as the structure of the universe.
Whoa, so the universe is like this giant interconnected web, always changing and evolving.
Pretty much.
But hold on, if that's the case, then how does that actually explain the universe as we know it?
Like space, time, gravity.
Exactly. All that stuff.
Well, that's where things get really interesting. Wolfram's saying those big concepts, they might not be fundamental after all.
What do you mean?
He calls them emergent phenomena. Like, they emerge from all those interactions happening within the hypergraph.
So wait, you're telling me space and time aren't the base of everything, but are more like outcomes of something deeper?
Exactly. It's a huge shift in thinking.
That's mind-blowing. So basically, even things like gravity and the speed of light, they're not just random laws.
Nope. In Wolfram's model, even the speed of light just pops out naturally from the way the hypergraph evolves.
Wow. Okay, so even the unchangeable laws of physics might be a result of this hypergraph thing. But what about the really mysterious stuff, like black holes? How does that fit in?
Well, in Wolfram's model, black holes are thought to be like points where the hypergraph branches off.
Branches off. Okay, so where does it go?
Potentially to totally separate universes, each one with its own set of rules, like different laws of physics in each one.
Hold up, are we talking parallel universes here? Like something out of, like, Doctor Strange?
You got it. It sounds like sci-fi, but the multiverse is a real possibility if Wolfram's right.
Whoa, so there could be countless other universes, maybe even with different versions of ourselves, living with completely different rules. That's insane. But if there are so many possibilities, how could we ever find our own universe in this mess?
That's where this concept of the rulio comes in. Imagine like an abstract space, but it holds all possible combinations of rules for a universe, like a catalog of every possible reality.
It's like a cosmic library of universes.
Yeah.
But how big are we talking? Can we even imagine the size of this rulio?
Imagine trying to find one specific atom in the entire observable universe. That's how tough it would be.
So finding our own universe in the rulio sounds kind of impossible. How could we even begin to look in a place that fast?
Well, Wolfram's got an idea for that too. He thinks artificial intelligence might be the key.
AI. Like, how could AI help us map the multiverse?
AI is really good at spotting patterns, right? So maybe it could pick up on connections and pathways within the rulio that we, as humans, wouldn't even see.
So AI could be our guide through the multiverse, like a cosmic GPS that navigates these crazy realities.
You got it. It could analyze the rulio structure, search for patterns that match up with specific universes, even ones with completely different laws of physics.
That's mind-blowing. So if AI can do that, I mean, what does that even mean for our understanding of physics, the whole nature of reality itself?
That's the big question, isn't it? And the really exciting thing is Wolfram's put all his research out in the open. Anyone can dive in.
So it's not just locked away in some lab somewhere. It's like an open invitation to explore this stuff.
Absolutely. Anyone can jump in and learn and maybe even contribute to understanding the universe a little better. I mean, it's incredible when you think about it, right? This hypergraph, this constantly changing network, could be the foundation for everything we see out there in the cosmos.
It really is. But we've been talking about the universe as this, like, interconnected web. But how does that actually translate to something like, I don't know, galaxies forming? Those giant swirling masses of stars and planets, they seem so far removed from this whole hypergraph idea.
Right. Well, imagine those points in the hypergraph, those fundamental building blocks, they start to cluster together, you know, over vast periods of time.
So are galaxies like cosmic traffic jams in the hypergraph? Like points just getting denser and denser in certain spots?
You could think of it that way. And instead of cars, we're talking stars, planets,
Ugh.
all drawn together by the rules of the hypergraph, rules that we eventually experience as gravity.
So gravity, it's not just a force acting on objects, it's more like a consequence of how these points in the hypergraph relate to each other.
Yeah, that's the idea. And it goes beyond just gravity, too. Wolfram thinks all the fundamental forces, electromagnetism, strong and weak nuclear forces, they all might stem from these same principles of the hypergraph.
Whoa, so the hypergraph isn't just some abstract model. It's directly tied to how the universe works on the most basic level.
Exactly. It even gives us a fresh perspective on one of the biggest mysteries in science, the origin of the universe.
The Big Bang. Okay, so does Wolfram's theory change how we think about that?
Well, instead of that traditional view of a singularity, that infinitely dense point exploding outwards, Wolfram's model suggests a more gradual process. Remember that first point in the hypergraph, the one that started it all?
Yeah, like the cosmic seed that everything sprouted from.
Right. Imagine that seed point slowly expanding and branching out, creating more connections, more points, kind of like a network of branches growing from that original seed.
So the Big Bang wasn't really a bang at all, more like this slow unfolding of the universe.
That's the gist, yeah. This gradual emergence of the universe from simple computational rules. That's one of the most profound parts of Wolfram's theory.
It really flips our understanding of the Big Bang on its head. But okay, so how does this theory deal with that rulial concept, that cosmic library of universes?
So remember we talked about how AI could be crucial for navigating that rulial? But we got to remember, AI right now is still, pretty young.
So we're not quite ready to send an AI out to map the multiverse just yet?
Not quite. Think of it like comparing a baby's first steps to an Olympic sprinter. Yeah. AI has tons of potential, but there's a long way to go.
But are you saying that eventually AI could get sophisticated enough to actually map the rulial, like find pathways to these other universes?
It's a real possibility. AI is all about finding patterns, connecting things that seem completely unrelated. So imagine AI looking at the structure of the rulial and finding patterns that match up with specific universes, even ones with completely different laws of physics.
That's amazing, like having a cosmic GPS to guide us through the multiverse. But this brings up another question. I mean, if we could find these other universes, what would that tell us about, intelligence itself? Could it emerge differently in those realities?
That's a great question. If intelligence arose in our universe, it stands to reason it could arise in others. And with the sheer vastness of the rulial, intelligence could take forms we can't even begin to imagine.
So exploring the rulial, it wouldn't just be about traveling through space and time, but like traveling through the evolution of intelligence.
Exactly. We could see the incredible diversity of what intelligence could look like across the multiverse.
It really connects everything, Physics, computation, intelligence, it's all part of this giant cosmic tapestry.
It's like the universe is trying to tell us something. Yeah. Whispering its secrets.
And AI could be the key to understanding those whispers, helping us not only understand the structure of the universe, but the very nature of intelligence itself.
That's a powerful thought, right? It just emphasizes how important it is to keep exploring, keep asking questions.
It's a journey full of possibilities, and I, for one, am excited to see where it takes us. But let's not forget the person who's really driving these mind-blowing ideas. It's kind of crazy to think about how ambitious Wolfram is with this. Like, what's pushing him to go after this theory of everything?
Well, he's got this insatiable curiosity, wants to understand the universe on the deepest level. It's not just about explaining what we see. It's about understanding the code, the language of reality itself.
So he's not just looking for the what, he wants the how, the actual rules that run the whole show.
Yeah. And that's what makes his approach so different. He's not after equations that just describe things. He wants the computational rules that actually generate those things.
So it's almost like he's trying to, hack the universe, find the source code that makes it all tick.
You could say that.
Yeah.
He's trying to crack the code of reality, figure out the program running the whole system.
Okay, but if Wolfram's right, if the universe is basically one giant computation, what does that mean for free will? Like, if everything follows a set of rules, are our choices even really ours?
That's the question, isn't it? And Wolfram's theory doesn't really give us a clear answer.
Yeah.
But it does offer a new way of thinking about it.
So how does free will fit into this whole computational universe idea?
Well, think of it like a video game, right? Characters in a game, they operate within the rules the developer set. But even with those limits, they still have some freedom.
Right. They can move around, make choices, even go off script sometimes.
Exactly. So maybe it's similar for us. We exist within the framework of the universe's rules, but inside that, we still have the ability to choose, take action, and shape our lives.
So free will, it's not necessarily an illusion. It could be an emergent property of this whole computational system.
It's a fascinating thought, right? It suggests that the universe is even more complex than we can imagine.
Wolfram's theory really challenges everything we think we know. Reality, free will, even intelligence itself. But there's something hopeful about it too, don't you think?
Definitely. It suggests that the universe isn't just some cold, uncaring machine. It's this dynamic, creative system with the potential to create complexity, beauty, maybe even consciousness itself.
It gives us this whole new perspective on where we fit in the grand scheme of things.
Exactly. And if we can actually crack this code, understand the universe's fundamental language, who knows what we could achieve?
Maybe we'll even end up chatting with other intelligent beings in those parallel universes.
Now that would be something.
This deep dive has really pushed our imaginations to the limit. We've gone from simple cellular automata to the mind-blowing vastness of the rulat. We've explored some of the most thought-provoking ideas in science today.
And we've seen just how ambitious and groundbreaking Wolfram's vision is. A vision that could completely change how we understand the universe and our place in it.
So as we wrap up this incredible journey, we want to encourage you to keep that curiosity alive. Keep asking questions, keep learning.
Remember, there's a whole universe of knowledge out there, and the journey of discovery never really ends.
Until next time, keep diving deep.